This is kind of boring, I know. Okay, so again, you guys, where do you think I would start? I like this point right here, and I like this point right here, because that's where the line actually crosses, like intersects with the grid. Here's the other thing. See how there's no numbers on this? So we can assume that they're counting by ones. On this one, you see that it's counting by, it's going 4, 8, so it has to be counting by 2, 4, 6, 8. This one, there's no numbers. So if there's no numbers, we're counting by ones. So you ready? Let's go. 1, 2, 3, 4. So I went up 4, but I went over to the left 1. So -4 over 1. Either one of these is fine. It's really up to you. Okay. How would you determine the slope or the rate of change for this one? What would you do? You were stretching, right, Jace? How do you find the slope, you guys? So we have a 2 and a 12, and I always start with the largest one and the smallest one. So what would be in the top? So what would be the top? 2. If this is your x and this is your y, what two numbers could you use? Yep, so I would do 60 minus 12, and then what would be on the bottom? You don't have to use those. You could have used 48 and 24. You could have done 24 and 12. I like to do the largest and the smallest because then that gives me the gambit of the entire line, okay? 60 minus 12 is? What is it? 48. And 10 minus 2 is?
8.
Which is 6. So it is going to be 6 feet per what? 6 feet per minute. Now they give you this graph right here for cameras. They have a film camera, they have a digital camera, and they want to find the average rate of change in the digital cameras from 2004 to 2009. So digital is this line right here. So you know that the average rate of change, and you can count, or you can do we can do what we did in that one problem. Then they want you to find the average rate of change in the number of film cameras and what do signs of each of the rate of change represent. Okay? But I don't want to do that one. I want to do number 7, and I want to do number 7 and 8 because these that you're going to have to rewrite it. Okay, number 7. What do you think I have to do in number 7? What? What do we need to do? We don't want to subtract 6. We want to do what? We actually want to divide by it. Because we're going to put it in y equals mx plus b. And all we're interested really is the number that's in front of the x. That's the rate of change. Okay. Now, on number 8, we're going to have to subtract. First of all, I want to know, is 8 in standard form? Is number 8 in standard form? X and Y are on the same side, but what is wrong with number 8? Why do I question if it's in standard form or not? Yes, it's because A is a fraction. And remember, in standard form, A can't be a fraction. So the first thing we're going to do is we're going to get rid of the 3/2. So now I have negative 5/4 y equal negative 3/2 x plus 15. What am I going to multiply everything by?
4 over 5.
And you guys, it's negative 4 over 5 because this was negative. So when we multiply by the reciprocals, they're the inverses, so we'll just end up with y because we'll end up with 1. Negative 3 times negative 4 is, and 2 times 5 is, I know you can reduce this, but I'm just going to multiply it out and then we'll reduce it. 5 times 4 is negative 60, right? I'm sorry, you're right. I said 5 times 4. 15 times negative 4 is negative 60, and then it's just over 5. The only thing I'm interested in is this 12 over 10 right now. Later on, I'll be interested in the 60 over 5, but right now all I'm interested in is the 12 over 10. And the 12 over 10 is what? What does that equal? 6. And you guys, because it's not in context, there's no graph, there's nothing like that. There's nothing that we need to do and say 4 per 3. It's just, we're gonna, for every 6 units we go up. So like on this one, for every 6 units we rise, we go to the right 5. For every 4 units we rise, we go 3 units to the right. Just little things like that. Okay, so we're almost done, and I'm almost put you back to sleep. I almost lulled you back to sleep, so we're almost done, okay? Promise? Now, what we're gonna do is this is the biggest one that they like on the SAT, and I know this because I have taken the SAT in the last couple of years. It was so much fun. So they like to give you the slope and to have you find the other ordered pair. So how do you think we're going to find the other ordered pair? What do you think we're gonna do? So we know that we have the slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's what we're gonna trade in. So what's our slope? What's our m in this problem? 2. I'm gonna write that as 2 over 1. Because isn't that, when slope's a whole number, slope goes over 1. Okay. What's y sub 2? 3. What's y sub 1? What's x sub 2? And what is x sub 1? There's a whole lot of ways that we can do this, you guys. So we're going to cross multiply. So I'm going to leave 2 over 1 equals 3 minus r. And what is 3 minus 6, you guys? Now we're going to cross multiply. We can cross multiply because there's an equal sign. So I'm going to do 1 times 3, so I'm going to go this way. 1 times 3 is 3. 1 times negative r is negative r. Now I'm going to go this way. 2 times negative 3 is negative 6. So R means, R is just that missing piece right here. So the ordered pair would be 6, 9, 3, 3. So R would be 9. In order to get a slope of 2, we would need this point to be 9. That's what that means. Okay, what I want you guys to do is I want you to try number 10. And then I'm going to work it out. I want you to try number 10 right now.